Hello, this is Marta with Classes for Teens. I'm here today with another pre-algebra review. This is number 5, and today we'll be talking about mixed numbers and applications. So first of all, mixed number is just a different way to write a fraction, and so it's just a notation game, writing it in different forms. So this is called an improper fraction, where there's just a numerator and a denominator. And they are asking us now to change that to a mixed number. A mixed number has a part that's a whole part and a fractional part. So we have to figure out how many wholes are in this. In other words, how many sixes will go into 37. So I would think about 37 divided by 6 goes in 6 times. So this is the part that comes out. This is our whole part right there. And then 6 times 6 is 36. We subtract that. We have one fractional part remaining. So this rewritten as a mixed number would be 6 whole parts and 1/6 as the fractional part. Now we're going to go the other direction, and you should have learned this already, so feel free to do some extra practice if you need to. Remember, after you're done with this, the notes for this are down below. You can print those out. They're linked below. And there's also a homework set to go with each of these. So I would urge you to practice that homework and check your answers, which are included with the homework. This isn't a mixed number. It has a whole and fractional part. We're supposed to write it as an improper fraction. So here we take the 7 that's out front, and we multiply by the denominator 7, and we get 49. So that's how many fractional pieces out of the whole of 7 if you cut each of them into 7 parts. So 49 little pieces plus the 3 that we already have would give us 52. So this is going to be equivalent to 52 sevenths if we write it in improper fraction form. Okay, so now we want, since we've reviewed that, to do some practice with our operations: multiplication, division, addition, subtraction. I'm not exactly sure why they have this in this order, but first we have a multiplication problem. And to multiply this, it's going to be kind of a mess because we have a mixed whole part, which has to go by the fractional part. It's easiest just to put this as an improper fraction and then multiply it. So with multiplication, make it into an improper fraction, each of them, and then multiply it. So 8 times 4 is 32. Plus 3 is 35. All right. And then I'm changing these, and I'm doing it in my head. 2 times 6 is 12. Plus the 1 is 13. That's 6. All right. So will anything in common divide those? That's 7 times 5. That doesn't help us. 13 is prime. So we might as well multiply these fractions by multiplying the numerators across. And let's see what we get when we do that. I'm grabbing my handy calculator. 35 times 13 is, oops, I messed up. All right. 455. And 6 times 8 is 48. Now, we need to reduce that. So if we want to do that the slow way, we're going to take 48 and divide it into 455 and see how many whole parts there are, right? 48 divides into 455. Try it on your calculator. 455 divided by 48 is... I got 9 point something. So it went in 9 whole times with not quite a little fraction beyond that, okay? So it went in 9 times. So 9 times 48 on my calculator is 432. And I'm going to subtract that to see the remaining part, that fractional part. So when I'm rewriting this answer, I'm going to have 9 as the whole part. Now I'm getting the fractional here. 5 minus 2 is 3. 3 from 5 is 2, with 23/48 remaining. So there's my answer, kind of scrunched in there. This calculator that I like is really great to check stuff with. Don't rely on it too heavily, but you can actually put in the original problem and have it multiply it, I think. I'm going to try this. We're going to pick this button above the 7, so I do the second option of the 7, and the whole part is 4, and the numerator go up with the toggle arrow here. The numerator is a 3, toggle down. Whoops, that didn't quite work. Oh, that didn't work. Okay, let's see. 4. Oh, I have to go arrow over. There we go. It's the arrow over. 3. I don't use this very often. And go down to 8. Okay, so I have that first fraction in there. And then I'm going to multiply that by, and here I go again with the second option of the 7, which gives me a spot to put the 2, and it's arrow over to 1 over 6. And then we're going to enter this, and it put it as an improper fraction. And you can make that go as to a mixed number, and I forget exactly how to do that. But I think it has to do with that button. I'm not going to worry with that right now. So you can check your answer with a calculator on any of these. All right, let's try the next one. It's a division. That division symbol almost looks like an addition, so let's write it more clearly. Division. So we're going to write these as improper fractions first. 3 times 4 is 12, 13, 14, 15. So that's going to be 15 fourths divided by 6 times 12 is 72, and 1 is 73 twelfths. Now we rewrite division of fractions, and we did this in one of the last videos, as multiplication. So I think of this as 15 fourths. Instead, divided by this, multiplied by the reciprocal. All right. And then I notice that 4 will divide into there once, and 4 will divide into 12 3 times. So I'm going to have in the numerator 15 times 3 is 45. And in the denominator, 73. And 73, I happen to know, is a prime number, so yeah, that'll be the reduced form of that answer. All right. So now we're ready to do, for some reason, multiplication and division are usually easier with fractions than addition and subtraction. So the next example is an addition problem. Let's look at that. We're adding the two fractions, and in this one, it's pretty easy just to add the numbers out front and then add the fractional parts. So we kind of think of this as regrouping if you want to, or if we just make the same denominator on these fractional parts with equivalent fractions, then we can just add them. So I'm going to take the 1/2. My least common denominator needs a 2 and a 7, so it's going to be 2 times 7 is 14. So I'm going to have to multiply by a 7 in the numerator and a 7 in the denominator, because again, that's like multiplying by 1. So 6 and 1/2 is the same as 6 and 7/14. All right, now let's look at the next one, which is 11 and 2/7. So I want to change 2/7 to be onto 14ths. So I need to multiply by denominator by 2, and I do the same thing to the numerator because that's like multiplying by 1. 2 times 2 is going to be 4/14. So this is going to be 11 and 4/14. Okay, now I'm simply going to add together the whole parts and add together the fractional parts. And I get 11/14. 17 and 11/14. Okay, we have one more here. Let's see if I can tip this camera any. Maybe. There we go. That's kind of showing it. Let's see, I'll move it a little way. I don't want to make a crash. Okay, here we have subtraction. And when I look at the whole numbers, that's easy. 16 minus 8, easy. 1/5 minus 2/5. 2/5 is more than 1/5. So that's not going to subtract very well. So we have two choices here. They're really equivalent. Do whatever makes the most sense to you. We can make these into improper fractions and simplify them. I think I'm going to think about the fact that if I think of the 16 and 1/5 as 15 and then 1 and 1/5, right? I'm going to take one of these out of 16, which is the same as 6/5. So I'm going to rewrite this as 15 and 6/5, right? So let's think about that again. I kind of flew through there. I took one out of the 16, and I cut it into 5 pieces, and I added it to that one. So I made one of these into the fractional part. So I changed it down to 15 and 6/5, which is the same. And if you don't like it that way, just get it into improper fraction mode. And the reason I did that is because now I can do the subtraction pretty easily. Slide this up a little. 15 minus 8. And then 6/5 minus 2/5. All right. There we go. Should be boxing off my answers, but I think I forgot on the last one. Here it is right there. Dumped it on. Okay. Let's go to the top of the next page. Well, same page, but top of the next column. These are applications, and that's what it said we were going to cover, mixed numbers, which we did, and some applications. This is just a review. This is not intended to teach this. It's just to help you remember it. Jeffrey has 2 packages. One weighs 2 2/3 ounces, and the other weighs 5/8 ounces. What is the total weight of the 2 packages? So always in a word problem, make sure you read it before you start trying to work it out. And they want the total weight, so that means I need to add the 2 weights together. 2 2/3 plus 5/8. Always start out by writing down what you're planning to do. That way, if you mess up, you get partial credit with your teacher. To add these fractions, they have to have the same denominator. So what number is divisible by 3 and 8? That would be 24. So I'm going to change 2/3 to be 24ths. That means I need to multiply by 8, which will give me 16 24ths. So 2 2/3 is the same as 2 16 24ths. And then we have 5/8. So let's go over here and look at that. 5/8 is how many 24ths? Well, to get the denominator I need to multiply it by a 3 in the numerator and the denominator. So that's the same as 15 24ths. So let's add those together. And 2 plus nothing is 2. 15 and 15 is 30. So that's 31 24ths. Oops. We can't have the numerator larger than the denominator in a mixed numeral. So I need to make one of those into a whole. So this 31 is the same as 24 24ths and, well, 7 24ths. Okay, so in other words, I'm breaking it up. So there's 1 and 7 24ths. So we have 3 plus 1 more. I'm sorry, 2 plus 1 more gives us 3 and 7 24ths. 3 and 7 24ths. Now I think it's the total weight, so I should put ounces here, squeeze in an OZ there, so that I put my units on the answer. And again, you can make your calculator do these because they can do fractional arithmetic and check it for you, which is handy. Okay. If John puts 3/4 pounds of roast beef on each sandwich, how many sandwiches can he make from 3 3/4? Okay. So we have a total of 3 3/4. And each time we make a sandwich is going to take 3/4. So we're taking the total weight of the roast beef, vegetarian here, so I don't eat this roast beef stuff, and divide by how many, we want to see how many sandwiches you can divide it into, right? How many can you divide it up? So divide it into groups of 3/4 of a pound, and that will tell us how many sandwiches can be made. Well, for division, we have to have improper fractions. So make yourself a mental note again. For multiplication and division, it's easiest to do it in improper fractions. So I'm going to make this into improper fractions. 3 times 4 is 12. 12 plus 3 is 15. Instead of divided by 3/4, I'm going to multiply by the reciprocal. I want to remind you that we're no longer using the x for multiplication. We use a dot when we move into algebra because we will be using x for a variable, and that would be too confusing. When I multiply fractions, if I have something divided by the same thing, it makes a 1. So I get 15 thirds, which seems a little weird. 15 divided by 3 is, oh, well, that works out nicely. 5 sandwiches. Oops, I have spelling trouble. Sandwiches. I'm just going to abbreviate it as stand, okay? It's going to make 5 sandwiches. Perfect. Okay, we have one more application on this page. Oh, 2 actually. Kind of didn't give myself enough room for that one. Anne writes 1 page in 2/3 of an hour. How many pages can she write in 3 1/3 hours? So that's another division, right? We want to see how many times will 2/3 fit into this time slot, okay? So I'm going to grab another piece of paper for this since I didn't leave enough room there. I'm going to be taking, this is number 9, 3 1/3 and dividing it into 2/3 of an hour chunks and see how many pages. 1 page in 2/3 of an hour, right? How many pages? Okay. So making these into improper fractions, that's going to be 10 thirds. Instead of divided, we change fractions to multiplying by the reciprocal. Cancel those, they make a 1, and we get 10 over 2, which equals to 5, and that's going to be 5 pages. Right, she has 3 1/3 hours, and every 2/3 of an hour she can do a page, so she can do 5 pages during that time period. Good. And the last one is an application for geometry, and some of you may have had geometry, maybe not, probably not at this point, just mixed into your elementary math. Find the perimeter. The perimeter means the distance around something, right? So it doesn't matter whether it's a square, a triangle, or some weird shaped thing, polygon. The perimeter tells you how far around. So what's the distance around this triangle in the figure? So they're really asking us to add those up, right? So let's do that. 6 plus, I'm just going to go around clockwise, 7 1/15 plus 10 1/5. Okay, so for adding fractions, we can add the whole parts and the fractional parts, but these need to be in the same unit. So I'm going to change 1/5 to be 15ths, so I can add it to the 15ths because the LCD is 15 there. So I need to multiply by 3, and so 1/5 is 3/15. So I'm going to rewrite that. We have 6 plus 7 1/15 plus 10 3/15. Okay, let's add the whole parts. 6 plus 7 is 13 plus 10 is 23. And then 1/15 plus 3/15 is 4/15. All right, that concludes our pre-algebra review of mixed numbers. Do remember to go down below and do the homework that's linked and practice it and check your answers. All right, I will see you for the next review when you're ready.